Hi everyone, this is the first of two videos. In this video, we'll be going over how to make a part and how to essentially make chapter 10 hands-on test drive number 1, the part from this exercise. And then we'll show how to make the part so that it translates nicely to the drawing that we'll make in the next video. And we'll also show how to add properties and parameters so that it can automatically propagate in the drawing we make in the next video. So in this video, we'll just be going over making chapter 10 hands-on test drive number 1. So that is this model right here. It's a relatively simple model. Although the drawing can seem pretty complicated, overall, making the part itself is pretty easy. So let's start by making the part. Let's take a minute, as always, to just think about our approach to making this part. In this case, the drawing really hints at where you should start, and that is from this face right here. We can make almost the entire, we can get almost the entire shape down by just making a sketch of this face and then extruding it to various amounts to get the shape. So again, there's more than one correct approach. I'll be making a sketch in this center here. At the center cross section, just imagine the shape having a cross section. Imagine the shape cut in half. Imagine this part cut in half right on top here, across, horizontally. I'll just be making that sketch and then extruding it both ways to get the shape, to get this part. So let's start by looking at dimensions, 21. Okay, the two circles are diameter 12, diameter 21. So let's start there. Let's make that our origin point. In this case, we have some flexibility with our with where we want to pick our origin point. I'm just gonna pick it to be the center point of our circles. So a good approach, a good thing to do is if you know you're gonna make a drawing from the parts that you're making currently, you want to check if you hit this view orientation tool. Oh, you can't move. Okay. You can hover around to different perspectives, to different views of your part model that is yet to be made. But it's a good idea to pick the isometric view and make sure your part model in the environment from this isometric view is what you want to be like the isometric view in your drawing. So as an example, basically this is the isometric view essentially of your drawing. Your drawing's going to have a front view, a top view, a side view, and possibly a bottom view, or maybe the other side view, maybe another side view, so left and right views, based on the complexity of your parts. But in this case, you want your isometric view to you want to make your part orientated so that your isometric view looks nice, and you can pull out all of these other views from your isometric view. Otherwise, once you're done with making the parts, it's going to be much harder. Actually, I don't know how to personally, but it's going to be very hard, very difficult, or maybe impossible to make it so that you can get like nice top, bottom, and side views, front views, and isometric views from your parts. So it's better to just start knowing which start with the correct orientation. Essentially, I want to start with the correct orientation. So in this case, sketch on to basically mimic the orientation that's given in the textbook. So I want this front plane to be the front view, this way. If you see here, view orientation, isometric view, as you can sort of tell already, when you extrude this out, it's gonna be very similar to this part right here, to this view right here. So again, you want to start knowing or be mindful of the orientation your parts will have, because it's very difficult to change, but very annoying to change it later on down the line. So start with the correct orientation. So again, 12 diameter, 12 millimeters, 21 millimeters. Okay, this arc here is 14 radius. It appears we can just do half of this and mirror it over the other side. That would be much easier than doing both sides. So let's make a center line. Keep in mind to make a center line, and then a radius in the arc here with a radius 14. So let's go back to our sketch, Control 8. Let's make a center line, or construction line, center line. Make sure it's vertically constrained. Nice. This is not going anywhere. Perfect. Let's make an arc. Let's do 3-point arc. In this case, I'm not sure if the center point is the same. Let's double check. Okay, so it seems like all three of these arcs or circles are concentric. So we start right here, go up to 14, click enter, click, pull out a little bit. We don't have to pick we don't have to make sure that this arc length is a certain amount just yet. Once we get the other lines down, we can then fully define this. Okay, let's see how long this horizontal length is. Let's see. So this length here is 1 millimeters. This whole length here is 12. This is 20. So going from the center line to the sideline here is 20. So we basically go off of that distance. So let's make some lines. One here, one here, one here. And I'm just going to get a general shape down. It's not going to be very accurate, but I think I have a good idea of how it looks like roughly. You can always go back and make it more accurate after you get a general shape down. Okay. So this side length here to the center point, to the center line distance is 20. This distance here is 20. Not 10, 20. There we go. This is still defined. This arc length here is not defined. Let's see if we can define that. Okay, we can define that by just setting this height, I think, to 25. So this height here should be 25. Okay, I think these two lines, okay, it seems like these lines are horizontally constrained, which means they will move together. Oh, never mind. You want these to be collinear. This way, these two lines will move together. Perfect. Okay, so this thing still moves, which means we're still missing a few dimensions, but we're not in a rush. So let's take it slow, nice and slow. So going from the center point of these circles to the bottom is 15. Let's do that. Center point to the bottom is 15. There you go. So now this is fully defined. Perfect. So as you add more dimensions, oftentimes it will become defined without you actively trying to define it. Fully defined without you actively trying, as long as you add the correct dimensions step by step. Okay, let's organize our dimensions because it gets very confusing and messy if you don't. So let's place these in strategic areas to be out of the way of the sketch. The bottom length here is 1. This length here is also 1. These seem to be chamfers. You can either chamfer these or you can directly build them into your sketch. This symbol here is for chamfer. We'll talk about that more about that next video. So let's see. So as indicated here, this angle here is 45 degrees. Okay. And because there's a center line here, we can assume if there's a center line, you only have to label half of the shape if it's symmetrical. You can instantly assume that because there's a center line right there, whatever dimensions are on either side will apply to the other symmetrical side as well. So in this case, both sides have this angle of 45 degrees. And this bottom here has an angle of 135 degrees. So these are all basically 45-degree angle chamfers. But you can either chamfer these or you can just draw them into your parts normally. Sketch them into your part normally. So let's check out dimensions again. This is 1. And this is also 1. Nice. So now we have this thing. Let's see. We can. Okay. Because they used this point here as a reference point, I believe it's easier personally for me to just sketch in these chamfers instead of using the chamfer tool. So I'll just manually put in the angles. Again, there's more than one way of doing these things. So based on where you start your angle line, you either get 45 degrees or 135. It's just based on like where you start on the circle, on the arc. And so let's make these the same as well. 135. Oops, these are 45s. And oops. Okay. Drag this back. Interesting. Pull this down. All right. Let's see what the dimensions we're missing. This is 8. This is 12. So let's add those. This is 8. And this is 12. Wait a minute. Yes. 12. I want to make sure that this point and the center point here are vertical. That way we can when we mirror this, this point will connect with the other side. So this is still free to move, still blue. So we want to constrain this somehow. This distance here, 12. Is it missing a dimension? Oh, no, the total is 45. The total is 42, I mean, sorry. 42 millimeters, which means. Huh. Interesting. What am I missing? 20, 12, 14, 45 degrees. It doesn't say how long this is. Am I missing something? All right. It looks like this is not dimensioned. Also missing something. Pretty sure it's missing a dimension here. No, nothing. Double check. 2, 6. Is it aligned with something? It is not aligned with something, with anything. 12. Yeah, it doesn't say what the length is here. But we do know this full length here is 21. Okay, we don't really need that part. So we're missing a dimension here. I am not sure what this is actually. We can actually get rid of this angle as well. If we make these two lines here parallel, we only need one dimension. Nice. So now it looks much cleaner. What is this length here though? Doesn't say, huh? We might just have to assume what it is. I don't think it matters too much in this case. Since this is not an assignment, I think, for you guys. So we can just give it an arbitrary. Oh, whoops, this is way too much. 4.5. Give it an arbitrary value. 12. I mean, it seems about right, actually. It's either 4.5 or something near that, whatever. So now we can mirror. Again, we're just going over the concepts here. It doesn't matter if you get the dimensions perfectly, get this part model perfectly accurate. So we just want to mirror the outline, and we mirror about the center line here. Check. Kaboosh. Done. Okay. We can directly go into features, extrude. And we can do a both side extrude. So make sure to select your contours correctly. So we want to do this outer ring, I think. Yep. And this outer ring we want to be. So there's a gap of 2. There's this little divot, little indent here of 2 millimeters. So 2 millimeter deduction from both sides, and the total length is 36. So the total length here on the inside here will be 32 because we're missing 2 inches from both sides. So instead of doing blind, we do midplane. And then for total diameter, we do, instead of 36, we do 32. All right. Make sure everything's fine. We don't want thin feature, we just want this. Nice. Now we go back and show the sketch. So again, extrude something else from the same sketch. And now we want to select the outline. So we don't want the contour that SOLIDWORKS selected for us. We want to choose our own contour, which is this. Midplane again. So for this, we want 36 because there's it protrudes out more so than the inner extrude. It's longer than the inner extrude. There we go. Now this basically is how our overall part looks like. So this is a very good, we're making good progress so far. Nice. So if you do go back into your view orientation tool and hover over isometric, as you can see in the picture, I guess, the labeling on the top left corner says isometric. So this is a view you'll get if you place it directly into your sketch. So this is the same view given in the book. So you want to make sure that when you're building your part, your isometric view looks like what you want to look like for the drawings. Basically, you're planning ahead. Even before you start making the parts, you're thinking about how your drawing should look like and how your drawing should best be oriented so that it's easier for the viewers and for you to make and to make out. So let's finish the parts. We're missing the holes, and those should be it, I think. Okay, so the holes are chamfered. Okay. Okay, so these are, we can make these using the hole features because I believe these are a certain type of hole. A certain type of hole that the hole tool can give us. So let's just put down some circles or some points for us to use as reference for the when we're using the whole tool. So let's make them. There's 6 from the side and 7 from the bottom. Okay. Let's sketch. We put our sketch directly on this top plane here. Since these two surfaces are on the same plane, we can just sketch on this one surface, this overall plane that's on the surface. So let's see, sketch, circle. We can just do, okay, 6 on side, 7 from. We can also use the mirror tool here. If we just make a center line, we can either mirror, before or after we use the whole feature, the whole tool. In this case, mirroring after using the whole tool will be easier because we don't have to select an extra 2 circles to a whole. Want to make this vertical, so it's fixed. This is not going anywhere as well. So make a circle, make a circle. Believe it's 6 from the top, 7 from the top, 6 from the side. 7 from the top, 6 from the side. Yep. Shucks. On the long side. So center point to the long side should be 6. And this height here should be 7. And for the 6, we can just make these 2 vertically constrained. They're on the same vertical line. Let's make these 2 circles equal as well. And then we can just dimension 1 these circles, which is 4.5 millimeters in diameter. Nice. Okay. So you have to be careful. This is the outer diameter of the circle, not the inner. So make sure to just keep that in mind and double check, possibly, to make sure that your circles are the right diameter. But this seems a little bit. Oh, no. Okay, so the inner circle is actually 4.5 millimeters because it doesn't look large enough. So I actually made a mistake here. It should be the inner circle that is 4.5 millimeters. Yep. Okay, actually, since we're already here, you can either use the hole tool or the chamfer or the extrude cut then chamfer combination. Let's try doing both. Let's try doing the hole tool first, and then we can do the other approach, which is extrude cut then chamfer. So first, let's finish the sketch by just mirroring these 2 circles about the center line. Okay, everything's fully defined. Check your bottom, fully defined. Nice. Okay. So let's start by going to features using the whole wizard. There you go. This is the countersink hole type. Positions, we choose the center point. We click on the surface, we choose these center points. So in this case, we don't need the circles, but the circles are just convenient in that circles also have a point, the center point built into it. So you can choose to either use extrude cut or a hole type. So it's basically, it's slightly more work than just putting down points, but it gives you more options. And I just like using circles as well. So again, there's more than one correct way of making these parts. So who knows? Maybe your way is much faster, and or you just prefer your way better. Up to you. So let's make sure these dimensions are correct. This diameter is not correct. So let's. Oh no, this distance here is not correct. Let's choose up to surface. So the hole goes all the way through until it hits the surface. Nice. So as you can see in this preview, the holes go all the way down until it hits the next surface and it stops right there. So that is what up to surface means. You can change the direction, but we don't really want to click on that option for this case. Okay. So tolerance and precision, this is not for us right now. We don't have to worry about that. Let's check the size though. The size is not correct. Let's make sure that this inner hole matches this outer diameter. This hole matches this diameter that we have with the circle, because as we had previously taken a look at it, we said that this diameter is actually the inner hole shape. So we're gonna change the size a little bit. So we're gonna change the standard to millimeters, so it's easier for us to determine the hole diameter. Let's see, ANSI metric should be fine. So we want to M4, it would seem. So this is a downside with using the hole feature. You have to, it doesn't, the screw the hole names and classifications are a little bit more confusing. As we'll go over later, it's, I think, more intuitive if you just use extrude cut than chamfering, but this is one way. Because, let's see, let's change the view. And this is one of the pros with using a circle instead of a point. You can tell if the circles align with the hole diameter. If the circle's diameter aligns with the hole's diameter, that your hole, this M4 here, is the correct measurement to go for. So we hit check. Now you have the desired holes, and we're essentially done with this part. Nope. Let's change our view again to isometric. I believe it is this one. Okay, this one. Nice. And this again looks just like pretty much how our given part model drawing looks like. Okay, so let's go over the other method, which is using extrude cut and then chamfering. So let's see. Make sure to select all 4 of these holes. Up to surface. Click the surface. Oh no, offset from surface. Nope, nope, nope. Up to surface. Okay, there we go. The holes will go up to the surface. And then we hit check. Then we chamfer. Chamfer these edges. Okay, so this chamfer is too long. I want to decrease this length here because you can't chamfer beyond the size of this, beyond the surface, beyond this object, basically. Gonna make this into a reasonable number. There we go. Let's check our sketch to see what the chamfer diameter is. 8.96. Wow, what a convenient number. So 8.96 divided by minus 4.5, that gives you 4.46. Divide that by 2 because you just want the difference in the radius, not diameter. So 4.46 divided by 2, 2.23. Want this length to be 2.23. And this is the other way you could have done it. Either way, it would have worked. But in the end, you get the same parts. So it's up to you which one you prefer. There's probably other ways, but these are two ways that most immediately comes to my mind. Just make sure we got all the parts, all the dimensions down. Yeah, everything looks fine. Okay. All right. So before we finish up this part model, to prepare it better for the sketch. So the first thing we did to prepare for the drawing, drawing. The first thing I did to better prepare it for the drawing is to make sure that the isometric view is a convenient view that can pull the front view and the side view and the top view from. So this is just a convenient orientation. And I chose that before I even started this, started making the part. Now we want to, going back to the Word document, add properties so the parameters can automatically propagate. So once you get in the drawing template that you guys will be given, there's going to be areas. First of all, there's going to be two main sections. One section where you put the material, the surface finish, and the mass. And then one area where you put the title, like who made the drawing, who made the part, who checked the part, the date, the iteration. We'll talk more about all those in the next video. But you want to be able to, if you want to have like properties automatically propagate in the drawing, properties such as the material used or the mass of the block, of the shape of this part, you have to add these manually into the properties of this document first. So I'll show you how to do that right now. It's gonna make more sense after I finish it and start the next video and show you guys how it connects. But as of now, I'm just gonna show you how to add properties for this part. So let's first begin by adding material, because we'll need that. We'll need to define a material for future parts we make. So let's just do, I don't know, plastic, because I hate the environment. Let's do, I don't know, PT. Wait, I wonder if styrofoam is a thing. Nope, okay. Probably is, just under a different name. Let's do with PET. Oops. Hit apply. Nice. I like this color too. Perfect. Hit Control Save. Make sure to constantly save throughout your work process. Otherwise, if SolidWorks decides to crap out, you're screwed. That has happened to me like a few times. SolidWorks is not the most consistent program, especially based on what computer you use. My computer is getting old now, so it's definitely not consistent. Make sure to always save. Okay, properties. You hit File. You come down here, and there's a Properties tab right here. You can also, I believe, go into Settings, switch up Properties. Screw it, never mind. File Properties. That's the most convenient way. So then you get this. Hopefully you get this window pop up. and 3 tabs basically. I usually just stick with custom. These two have like small variations in what they can apply to. I just stick with custom. I think this is basically what you need, all that you need for now and for the scope of this class. So you can add various properties such as material, and you have it linked actually. If you hit this drop-down menu, SolidWorks knows have various variables ready for you. They can just pick and it'll automatically associate with this property name. So this property name is material. If you choose the first option, which is material, whatever material you choose in your part modeling environment, part sketching environment, whatever material you choose there, it will automatically be assigned to this variable here. And it's now linked to this property name. And if you save it, this is now a property, which means as you change the material, if you ever change the material of your part in the future, if you make a drawing from that, it will automatically change and repropagate a new material name in your drawing. So that's just something convenient that you might want to consider, because you have to make parts and part drawings for your own project model, for your own project. So you can also add mass. Go into mass, there we go. And again, you don't always have to choose what SolidWorks has to offer you. If you want to do something like, let's say, surface finish, you can just add your own number. Let's say like I don't know, sanded or something. Or I don't know, like gold plated. And that works too. And once you hit OK, these will now be associated with, these properties will be associated with your part, with your parts. You can also add things such as like part number. Again, you can assign your own part number. So you can do like some numbers that you like, 1166, and then this can be your like first 4 numbers, and then your first part in this series, 1166. And you can do this for like the next part. You can do 11662, 11663, 11664. So everything will be nice and organized. You'll have a part number. You'll have a space where you have to put down the part number in your drawing. You can also add something like iteration, as in like how often, which version of the part model this is. If you've made like 3 changes, if you made 3 changes to it, it will be the like 3rd iteration, with the first untouched part model iteration being version dash. I'll show that in the next video. So this will be our unchanged original model version, because most likely your first model might not work as you wanted it to. So you have to make changes to it. And as you make changes, you should document and resave new documents, new part models and new drawings. So you get to keep your old progress. You can always refer back to your older versions, just in case your new version sucks even more than your old version. You want to be able to refer back to those old versions and not save on top of the same documents and save over, rewrite the old documents. So once you hit OK, everything saves. Make sure you hit Control Save, and that is, we will end it here for the first video. Again, we made a part from chapter 10, hands-on test drive 1. I showed you some approaches that make the part more translate much more nicely to the drawing. And we've now know we now know how to add properties so the parameters can automatically propagate in our drawing in the next video. So this is it. I'm gonna head out and see you in the next video.